friends. Today I would be discussing a new concept, a concept called as structures. What is this, sir? Structures. Why do we require structures, sir? You may ask. I will tell you why we require structures. Before that, I would give you a scenario. I want to store maybe the marks of 10 students, the age of 10 students, and the height of 10 students. Assume I want to store the marks, age, and height. I want to store 10 students. How to do it, if you'll ask me? I can do it using two styles. This is the first method, in which I can do it. If you want to store the marks of 10 students, then like this I can create 10 variables: A, B, C, D, E, F, G, H, I, J, like this. 10 variables I can create. In one variable, marks of one student I can keep. Problem is solved. Correct. I also want to store the age of 10 students. The same 10 students, age I want to store. Oh, the same 10 students' age means either int or float, your wish. I will just declare it as int and I will continue. K, L, M, N, O, P, Q, R, S, T. In these variables, those students' age I would be storing. Oh, I also want to store the height of the 10 students. Those 10 students' height I want to store. Oh, those 10 students' height if I have to store, then I will maybe declare the height as of type float. And in that, U, V, W, X, Y, Z, AA, AB, AC, AD. Like this I will store. This is the way in which marks of 10 students, the same 10 students' age, the same 10 students' height I can be storing. Now, okay, sir, what is there, sir? You may ask. Say, supposing I will ask you the marks, age, and height of the 7th student. In which variable it is? Tell me. Marks of the 7th student, age of the 7th student, height of the 7th student. If I will ask in which variable it is, I know many of you are now trying to see which variable, because I am hiding those variables behind my back, so you are trying to see. In other words, what I mean to say is that this approach is not a proper approach. Whenever I want to store large quantities of data, I should not be creating individual variables like this. I should not be creating, because first of all, creation is a headache. After creation, if you keep the data, later if I will ask you in which variable what data is present, you will only not know it. That is the problem with this first method, which is also called as the traditional approach. No doubt, the traditional approach is a good approach, provided you want to store few variables, few data. If you want to store 3 variables, 4 variables, okay. Like this 30 variables if you will create, how difficult it would be. Remember, I told only 10 students. If I tell 100 students, then 100 variables you should create to store the marks. 100 variables you should create to store the age. 100 variables you should create to store the height. Okay, maybe you have a lot of time in life, you will create it. Suddenly I will ask you, 87th students' marks, age, height I want. In which variable is it present? If I will ask, 100% you will find it difficult to tell. Which is why I am telling the traditional method of variable creation is a good method of variable creation, provided we are creating few variables. If we are creating numerous variables, then don't go for the traditional approach. Then what to do, sir? what to do means you can go for the array approach. Correct sir, arrays we will use sir, you may tell, but unfortunately in this case even array I can't use. Why sir, you may ask. Why is because here if you notice, the marks of the fellow is an integer, the age of the fellow is an integer, height is a float. Remember, arrays can store only similar type of data. They can't store different types of data. It can't store int and float, it can't store. Whenever you have heterogeneous data like this, some of you may tell, sir, create 3 arrays, sir. 3 arrays I can't create. One array to store the marks, another array to store the age, another array to store the height. I should not, because all these are related to the same group of students. Why should I create 3 arrays for the same group of students? Rather, I would like to create only one array. In that array only, the marks also should be there, age also should be there, height also should be there. How is it possible, sir? You may ask. How it is possible is what you have to understand. Before C language came into existence, we had a language called B language. In B language, what we had was only this traditional approach. If only traditional approach is available in a programming language, and if I have to store the data of say 1000 students, imagine how many variables I will have to create. Also I have to memorize in which variable what is present. All that I had to memorize. People were frustrated with B language. That is the time that Dennis Ritchie came. He told, no, don't use B language, use my language, C language, use it, he told. People asked, why should we use your language? He told, in my language, I have provided a concept called as structures. Using structures, such situations easily you can manage. That is what he told. People asked him, oh, is it? How to use structures? He told, look, structures is very simple. If you want to create a structure, just tell struct. That is what he told. Just tell struct. And you have to give a name to the structure. What name to give? Give a suitable name. After all, you are storing student details. So, you better give the name as student itself. And then he told, like this open bracket you should put, like this closing bracket you should put, and end it with a semicolon. This is the syntax, or in other words, this is the way in which a structure is created. And then he asked, what is it that you want to store about the students? We told, we want to store first the marks of the students. So he told, oh, you want to store the marks? Then he declared it, int marks. Like this, he declared it inside. Then he asked, what else do you want to store? People told, we wanted to store the age. So he marked it, oh, int age. Like this, he did it. Next, he asked people, what else would you like to store about the students? People told, we also want to store the height. Then Dennis Ritchie told, okay, like this, float height, like this. So easy in its creation. You may tell, sir, what are you telling? So easy in its creation? Okay. How much memory will be allocated, sir, for this structure? You may ask. Please understand, it is just a structure. It is just a blueprint. Memory won't be allocated. If memory has to be allocated, you should create variables of this structure. What is it, sir? We didn't understand. Listen. How many students' details are you interested in storing totally? Here, this example that I have written is for 10 students. Correct. If you want to store the details of 10 students, you know, then after creating the structure, below that you tell struct student type. I will create one S. Remember, this is the variable S, which is of student type. But this S can hold the details of only one student. We want to hold the details of 10 students. Oh, very simple. 10 students means you tell S of 10, that's it. S of 10. Oh, now will memory be allocated, sir? Yes. After all, you have created an array, so memory will be allocated. How many blocks, sir? Totally 10 blocks would be allocated like this. Totally 10 blocks would be allocated. This is only our array called as S. This is the first block. This is the second block. Like that, numerous blocks would be there, and then you know this is the last block. Technically speaking, I would call this as S of 0. I would call this as S of 1. Like that, if I would tell you, no, this would be called as S of 9. Oh, correct, sir. What will be there, sir? Here inside this, what will be there? Here, what will be there? Here, what will be there, sir? You may ask. Remember, within each block, what will be there? That only you have told here. In other words, within this, I will have marks, age, height. That is what would be there here. In other words, here, I would be having space for marks, space for age, and also space for height. And please understand, integer in C language is allocated 2 bytes. So 2 bytes like this would be allocated for marks, 2 bytes like this would be allocated for age, and float, remember, float is 4 bytes. So 4 bytes like this would be allocated for height. Oh, okay, sir. What will be there here, sir? Remember, in every block, same things only would be there. In other words, here also 2 bytes for the marks, 2 bytes for the age, and 4 bytes for the height. Of course, I am not showing the segregation in this. Like that, next block, next block, next block, even the last block, 2 bytes for the marks, 2 bytes for the age, and 4 bytes. Remember, this entire block, if you consider, it is called S of 0. This entire block, if you consider, it is called S of 1. Simply, slightly like this I will write, so that you can identify the block boundary correctly. Simply, slightly extra I am writing, so that you can identify the block boundary correctly. But technically speaking, if you want to access only this region if you want to access, you can tell it as S of 0 dot marks. That is the way you can access this region. If you'll ask me, sir, this region, that region, S of 0 dot age. If you'll ask, sir, this region means S of 0 dot height. Like that I can access. Oh, okay, sir. This one, sir, this one also I can tell S of 1 dot marks. Similarly, this is S of 1 dot age. Similarly, this is S of 1 dot height. What is the difficulty? Similarly, this one also I can access it by telling S of 9 dot marks. Similarly, S of 9 dot age, and then S of 9 dot height. That is what I can tell. So simple. If in case in this method I will tell you, please, sorry, not 10 students, 100 students you please prepare. If I will tell, how frustrated you will get. Because if I tell 100 students, then 100 variables plus 100 variables plus 100 variables, 300 variables you have to create. Such a headache. Moreover, in which variable what you have stored, you only won't know. Here if I tell, no, sorry, not 10 students, 100 students if I tell, very simple, only one extra 0 you will put here, that's all. Say here 100 students are there in this style, and I will ask you 87th students' marks, age, height. In which variable is it present? If I will ask, you will not be able to tell. Whereas in this method, if I will ask you 87th students' marks, age, height, in which variable is it there? If I will ask you, you will tell, oh, 87th students' marks, you have it in S of 86 dot marks. S of 86 dot age, S of 86 dot height. Here you will have the marks, age and height of the 87th student. Remember, array begins from 0. So 87th students' details would be at S of 86th block. Very simple. This is the benefit of structures. So whenever you have to create, or whenever you want to hold data which are of heterogeneous nature. Heterogeneous means different. Int, float, char, like that, different. Say I want to store the sex of the student. Then char sex is going to come. M for male, F for female. Heterogeneous data. But all that heterogeneous data is with respect to the same group of people. If that is the case, don't create separate arrays. Also don't create the separate variables. That would be even more disastrous. Create a structure. Put all that heterogeneous in that. And then create an array. Not an array of primitive data types like int, float. Not an array of that. Rather, create an array of structures. Previously, I have taught you how to read the declaration statements in one of my lectures. I have taught you. That way, if you read this, I told you always you should begin reading from the variable, keep on going ahead till you hit the dead end. When you hit the dead end, get back. That is what I have told. So that way, if you read, you will read it as S is a array of 10 students. Correct? S is an array of 10 students. Of course, you will have to read it as S is an array of 10 student structure. That's okay. I mean, a student structure, correct. This is student's structure only. What else is it? I just told you, in my style, if you read also, correct only it is. S is an array of 10 students. This is the benefit. So, when to use structures, if you'll ask me? When you have a real life entity. Student is a real life entity. But the data of that real life entity is heterogeneous. Sex is character, marks is integer, height is float, heterogeneous in nature. If that is the case, create a structure, put all that quantity inside the structure. To create a structure, we should use struct keyword. Give a name to the structure, open bracket, close bracket, semicolon. That is the syntax. That is the rule that Dennis Ritchie has told. Inside that, you put whatever you want. But remember, no memory would have been allocated for the structure. Memory will always get allocated when you create variable or when you create array, memory gets allocated. An easy way to manage lots of data. This approach is what I am calling as the second method. Or in other words, this is what I would call it as the structure approach. The structure approach. I hope all of you have been able to understand it. Quickly copy. All right. I hope all of you have been able to understand this. Now, I will give you a scenario and you have to create a structure for that. The scenario is this. I want to store the name of three students. Three students' names, three students' marks, and three students' age. That is what I want to store this time. I repeat, name I want to store, marks I want to store, age I want to store. Tell me, how do you store the name? Name means character, correct. So notice, like this I can tell. Character name. Many students will tell like this and they will stop off, which is a mistake, because nobody's name is made up of a single character. All our names are array of characters. Whose name is of single character? Everybody's name is array only. In other words, I will have to tell name is a array of maybe 10 characters like this. I want to store the marks, so I can tell int marks. I want to store the age, so I can tell int age. I want to do it for 3 students. Oh, if that is the case, then I can just tell here struct student. Like this I can create it. Open bracket, close bracket, semicolon. And then I can tell here struct student. Struct student type s of 3. Like this I can tell. If you will tell like this, memory gets allocated for 3 students. How is the memory allocation going to look, sir, if you will ask? Notice, memory allocation is going to look like this. Say, this is only our array called as S. How many blocks are there in this array if you will ask me? S of 3 means 3 blocks. Like this, 3 blocks are there. Technically speaking, this is S of 0, this is S of 1, this is S of 2. So totally 3 blocks we have. What all you have, sir? Here you may ask. Here, what all I have only, that is what only I have shown here. Name, marks, age would be there here. For name, how much memory, sir, if you will ask? Remember, for name, totally you are only telling 10 bytes. So, like this, 10 bytes would be allocated for the name. Like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes would be allocated. Marks. Marks, as you know, integer. So 2 bytes would be getting allocated like this. Similarly, age, like this, 2 bytes would be getting allocated. Here also, same thing for name and then for marks and age. Similarly, for name and then marks and age. And then as I have told you, technically, this is S of 0 dot name. This is S of 0 dot marks. This is S of 0 dot age. Same case here also. This is S of 2 dot name. This is S of 2 dot marks. This is S of 2 dot age. Oh, okay, sir. Fine. Whatever you have told, we have been able to understand. Sir, I want to fill value into this, sir. What to do, sir? You may ask. If you want to fill values into it, you can do it in many styles. This is the first method in which value can be filled inside that. If you want to fill value, don't tell semicolon. Rather, you tell equal to. And inside this you can tell name Sachin, marks 25, age 35. Assume like this, I tell. How is it going to go and get placed, sir? You may ask. like this. Sachin, S A C H I N, null. Because in C language I have told you, whenever you put something in double quotes, at the end automatically null is going to come. Next, 25 is the marks. Don't think 25 gets stored here. Only because vacancy is there here, it doesn't get stored. It will go and get stored here only. Sir, then these bytes are wasted. That is only the limitation of an array, that you have to declare it, and later if you use it partially, the remaining part will go a waste. That is a limitation of the array. Array that way has many limitations, which is why linked list data structure came into existence. Next, it is that data structure only which I am going to teach you, the linked list. But then before that I require structures there in linked list, which is why I am just speaking about structures now. Oh, okay, sir. Next, 35, sir. 35, is going to get stored here. Sir, in the next block also I want to store, sir. If you will tell, then comma. And then here you can tell UV 24, 34. Like this you can tell. And I need not tell what is going to happen in this case. UV. And then here it is 24, here it is 34. And then next one also, sir. Next one means like this you tell Virat 23, 33, something like that you tell. In which case here also null, here Virat 23, 33. It is over. So close this, put a semicolon. Matter is over. This is one way in which you can put values inside a structure. This is one way. Oh, what other ways are there, sir? What other ways are there? I will tell you what other ways are there. Please be quick. All right. I hope all of you have been able to understand. There are no issues. What is the second method, sir, in which we can fill values? You may ask. Please pay attention. The first method all of you have understood. Now, the second method, notice. In the second method, I created the structure. After that, I told struct student yes, and all this I have done. I need not be doing all this in the next line like this. Oh, then how else will you do it, sir? If you'll ask. Please notice, after putting this closing bracket, don't put semicolon. Rather, here itself you tell, I want one array S of 3 students. Even this is also possible, though it is not that readable. Certainly the first method that I taught you is more readable, but this is also possible. We can do it like this also, where here you have told S of 3, and then here only you have told Sachin, and then 25, 35, and then UV, and then 24, 34, and then Virat, and then 23, 33 you have told, and then you have closed this, and then you have put once for all that semicolon. This way if you do also, same way memory is going to get allocated, no change. This is only our second approach. Please be quick. All right, I think all of you have been able to understand this. Okay sir, what is the third method, sir, you may ask. Third method, I would write the full-fledged program itself, and I would also execute it and demonstrate the program also. Pay attention. A full-fledged program itself I would write off for the third method. Notice, this is the way I can be doing it. This is our third method. In this, I would begin by telling hash include stdio.h. After that, it is void main. In the main function, first I will create one structure called as student. In the student structure, as normal, I will create character name of 10, and then I will create int marks, and then I will create int age, and then as normal I will create struct student type s of 3. Like this I would be creating. After that, as normal, I will tell clear screen. After clearing the screen, I have to take the input from the programmer, but not for just one student, for 3 students I have to take. Hence, I will also have to declare here one variable called as I, and then I will tell clear screen, and then here for I is equal to 0 up to 2 I plus plus. Why 0 to 2, sir, you may ask. Here you only say 0 to 2, that's why. Oh, correct, sir. What will you do, sir, you may ask. Each time I am going to ask the programmer. Programmer, enter the name, marks, and age. Like this I will ask the programmer. Whatever the programmer is going to enter, I will scan it. Collect the name as %s. Collect the marks as %d. Collect the age as %d. Where to keep it, sir, you may ask. %s, first I will keep it in s of I dot name, because name has to be kept in s of I dot name. Second is marks. Where to keep it, sir? Ampersand s of I dot marks. That is where I will keep. Age, where will you keep it, sir? Ampersand s of I dot age. That is where I would be keeping it. Some of you may tell, Sir, for this ampersand you told. For s of I dot name ampersand only you have not told. Long back itself I have clarified it. Whenever it is percentage s format specifier, no need to tell ampersand. Why, sir? That in my C aptitude videos you will understand. Till then you have to have patience. I really can't now divert myself and tell why ampersand is not required in case of percentages. It will be clear, everything will be clear, don't worry. But then I have to teach in a gradual process. I know some small doubts could be there in either this program or some program previously also. You could have some small doubts. It's not that I don't know that you don't have doubts. You have it, but what I also know is that each and every doubt is going to get cleared as the videos proceed. Ultimately, by the time all the videos get over, you will not have even a single doubt. That is what I can ensure you. Anyway, this is the closure of the for loop. You know, for the first time I is 0. So in s of 0's name, s of 0's marks, s of 0's age, all that will go and sit. Next time when you loop, I becomes 1. So in s of 1's name, s of 1's marks, s of 1's age, all that will go and sit. Next, as you know, similarly, I becomes 2, so everything goes and sits there. So this is another way in which I can take the input. In fact, I can print it also, I can also print it. How, sir, you may ask? Like this, for I is equal to 0 till I less than or equal to 2, I plus plus. I can print it by telling printf. First only I will tell of slash n, percentage s slash t, percentage d slash t, percentage d slash n, like that I will tell. So first name will come space, marks will come space, age will come, slash n means next name will come on the next line, like that. And what all to print? First I will print s of I dot name. Next I will print s of I dot marks. Next I will print s of I dot age. I would be printing all this. This is the closure of it. And as normal, at the end I will tell get ch. This is the closure of the program itself. So this part of it is collecting the input and putting it in the memory. This part of it is printing it for us. This is the third way in which we can be doing it. I hope all of you have been able to understand. There is no confusion. Sir, is it really going to work, sir? You may ask. Yes, it would be working. Notice it. This is the same program which has been typed. If you go above, you would notice that it is the same program. Now when I will compile, no issues. When I will execute, it is asking the name, marks and age. Name Sachin, and then marks it is 25, age 35, enter key. Again it is asking for the second time. This data has already gone and sat in that memory location, it. So next, again it is UV 24, 34, enter. This data also would have gone and sat. Next again it is asking because the loop is progressing. This time I will enter Virat 23, 33. And now if I press enter key, data will go and sit. Control will come out of the first loop. It will enter the second loop. Second loop will print all this for us. Notice like this. I hope all of you have been able to understand this approach as well. Please be very quick. Alright. So I think all of you have been able to understand all the three approaches. Now I would like to execute the same program using pointers this time. But I have told you pointer method means 3 steps. First of all, I will create a pointer. This time I won't create an integer pointer or a character pointer or a float pointer. I won't create. I will create a pointer which can point to student. How, sir? Like this I can create. Struct student type one pointer p I can be creating. Like that I can be creating. I have taught you the technique of reading this. Long back I have taught you. Start from here, proceed. When you hit the dead end, get back. So p is a pointer to student structure. So p is a pointer which can point to the student's structure. Oh, to which student is it pointing, sir? I told you, when you create the pointer, it would be dangling. You should make it to point to that 0th student. How, sir? You may ask. How means like this. Just a minute. This clear screen, you know. I would slightly just write it here. Clear screen. It is my duty to make this pointer point to this location. Means to S of 0 it should be pointing. So like this I will tell. For the pointer I am giving the address of the 0th student. Like that I will tell. Remember, for a pointer always you are supposed to give the address only. In other words, 0th student's address if you are giving to the pointer, it means that the pointer is pointing to the 0th student. That is the meaning of it. He is pointing to the 0th student. That is the meaning. Oh, okay, sir. Next what, sir? You may ask. I will ask the name, marks and age. After asking the name, marks and age, you know, I want to put it here. I want to put it here. I want to put it here. The name of this location is S of 0 dot name, or if you ask me, I can also tell the name of this is P arrow name. The name of this is P's A marks. Similarly, the name of this is P's age. Whenever you want to access something within the structure through a pointer, you should use arrow operator. That is the rule that Dennis Ritchie has given us. So what I would do here is that I won't tell put it in S of I, all that I won't tell. Rather, I will tell put it in P arrow name. Put it in P ampersand P. That ampersand, let it be there. P arrow marks. Here also, let that ampersand be there. P arrow age. Like this I will have to tell. Oh, okay, sir. We didn't know that whenever you want to access something which is present within a structure through a pointer, we should use arrow operator. We didn't know, sir. Now we came to know. Correct. Now you have come to know. Next what, sir? Will it now work, sir? No. You should be careful that this time, you know, before looping back, it is your duty to increment the pointer. It is your duty to increment the pointer. Why, sir? Why should I increment the pointer, sir? I will increment I, sir, you will tell. But I, if you increment, what is the use? You are using pointer. Last time you were telling S of I. So first time S of 0, next time S of 1, next time S of 2 it was becoming. But this time I am not actually using. I am using the pointer. You should increment the pointer. Sir, what will happen, sir, if I don't increment the pointer? If you will not increment, the pointer will be there only, but the loop will loop. And again the name, marks and age, you know, UV 2434 will overwrite of Sachin. If you will not increment the pointer, pointer will be there only. So it will overwrite. Next when you tell Virat, Virat will also overwrite UV. In fact, Sachin first you would have written, there only you would have written UV, there only you would have written Virat, you would never have used the other blocks. That is the reason as to why you have to increment the pointer. Okay, sir. If I will increment the pointer, Will this pointer point to the next location, sir? You may ask. Please understand one thing. That pointer that you have, it is not a character pointer. Look at this. P is a pointer to student it is. If it was a character pointer, if you will increment, it will point to the next character. If it was an integer pointer, if you will increment, it will point to the next integer. If it is a float pointer, if you will increment, it will point to the next float. If it is a student pointer, if you increment, it will point to the next student. So don't think that this plus plus p is going to increment the pointer to the next location. If it increments to the next location, it is meaningless. The plus plus p is going to make this pointer to point to the next student. It's going to make it to point to the next student. How come the pointer will know, sir? I have to point to the next student. Remember, where the pointer next will point depends upon the data type of the pointer. All this also I have discussed it in my aptitude videos. When you increment a pointer, next where it will point depends upon its data type. For example, if you will increment a student pointer, it will point to the next student only. Oh, okay, sir. Next what? Again, name, marks, age you will ask. This time if you tell p arrow name, this is only p arrow name. This is only p arrow marks. This is only p arrow age. After that, sir, after that again plus plus p you have told. Because you have told plus plus p, the pointer will point to the next student. And then again the name, marks and age, you will put it in p arrow name, p arrow marks, p arrow age. You would be putting it. So this location, either you can tell s of 2 dot, s of 2 dot, or as I have just now told you, you can also tell it as p arrow name, p arrow marks, p arrow age. You can be telling it. Oh, okay, sir, we understood it. Next what, sir? Next you have to print it. But here also you should be careful while printing. If you want to print it using pointers, it is your duty to take back the pointer to its original location. Because pointer would have gone ahead. If you will tell simply, foolishly, here also take out s of I, take out s of I, take out s of I, if you will tell, and if you will tell, I will tell it as p arrow name, p arrow marks, p arrow age, that would be meaningless. Your pointer would have proceeded ahead, so all the data will not get printed. It will start printing from there onwards, and into the garbage region it will go off. In other words, I will tell again for the pointer, give the address of the 0th student. Like this I will tell. Oh, okay, sir. If I do like that, what will happen, sir? The pointer which has come here will now again go back to the 0th student. It would go back. It will go back to the 0th student. And then when you will print, all this would get printed. P arrow name means that name. P arrow marks means that marks that age. But then while you are looping, you will again have to tell plus plus p. Because you want the pointer to next go to the next one. Otherwise, how will the next one get printed? Here I will have to close it. This is the way in which whatever is present within a structure can be accessed through a pointer. I told you, always pointer access involves 3 steps. Creation of a pointer. When you create, it will be dangling. Assigning it an address and making it specific. And then dereferencing the pointer and accessing the data. These are the 3 steps. Creation I have done here. Assigning the address I have done here. Dereferencing, this time I am not using star operator, rather I am using arrow operator. Star is used if it is not on structures, whereas arrow should be used on accessing the members of a structure. These are all called as members of a structure. If the members have to be accessed through a pointer, then you have to make use of arrow operator. That is what Dennis Ritchie has told. I hope I am completely clear. No confusion in this. Would it be executing, sir? If you will ask, yes, it would be executing. Please notice the changes have been made. Now when I will compile, no issues. When I will execute, the same story it is asking. The same input I would be giving. Sachin 25, 35. Similarly, UV 24, 34. Similarly, Virat 23, 33. Like this, if I will give 100%, the same output as what we have got previously, we would be getting it. I hope all of you have been able to understand the basics of structures. In structure itself, many more things are there. Anonymous structure and inner structure, nested structure, so many things are there. All those issues I would be discussing in the aptitude videos. When you listen to those videos, you would understand. Here we are not discussing the language in depth. Rather, we are only understanding the features of a language in order to increase our programming skills. So in C language, I have told you there are two sets of videos. One is a set of video to understand C language in depth. Another one is how to use C language and do programming. It is that aspect of programming that we are trying to focus upon. Please be very quick. Maybe I can call this as the fourth method. Alright, so I hope this video is completely clear. I know some of you would be thinking that what this fellow he was discussing data structures, stacks, queues, circular queues. Instead of discussing the next data structure, suddenly he shifted off to a new topic called as structures. Suddenly something never would I do. There is a planning to everything that is being done. For a student to understand linked lists, basics of structures was required. That is the reason why I have taught structures. In my next video, I would be telling you as to what is the limitation of the array data structure. And because of that limitation of the array data structure, only linked list data structure came into existence. How is it that the linked list data structure can overcome the limitations of arrays? All that is what I should be telling you. I would be making that clear. I hope all of you have been able to understand this. Thank you very much.